Two-axis milling. In this video, we will learn how to create a two-axis milling toolpath, including how to insert the operation, define the feature, set parameters, verify the path, output the NC code and operation list. Now, let's begin. This is the product with a few slots and holes. Its material is aluminum. We will use two-axis milling operations to machine it. First thing is to create a new CAM plan. Right-click on a blank area of the work window. Pick CAM plan, then select the default template. Click OK to create it. This is the CAM environment. First, create a stock. Pick Setup ribbon, click Stock command. Default stock is created. Here we can adjust the stock size. Set the length to 360, 5 millimeters for each side. Set the width to 150, also 5 millimeters for each side. Then set the depth to 30, only 5 millimeters for the positive Z direction. Check the stock. Click OK to finish the definition. In the pop-up window, click OK and hide the stock. Next, create the machining operations. Insert the first operation, the zigzag operation. Then click the Create button to define the machining feature. Select the profile. Place the cursor on the outer edge and press Shift, then left-click the Highlight Curves. All edges will be selected. This is Chain Select. In the Profile Feature dialog, make sure the type is Contain, then click OK. Next, define the tool. Name it D20. Set the radius to 0 and cutter diameter to 20 millimeters. Click OK. Then click Yes to calculate the toolpath. This is the generated toolpath. If this is not your desired path, you can modify the parameters. In the CAM Manager, double-click on the parameter and select Limiting. The Set Tool Location type is Past Boundary. Overhang value 10. Now we click Calculate again. This toolpath is much better. Double-click this icon to hide the toolpath. Next, create the second operation, the spiral cut operation. Define the machining feature using the profile method. Select these two slots. Make sure the type is Contain, then click OK to finish the feature definition. Now select D20 from the tool list. Don't directly calculate the toolpath, for first we need to modify the cutting parameter. In the Primary tab, set the step over to 35%. Step down to 5 millimeters. On the Limiting tab, define the top and bottom boundary. In the Path Setting tab, set the cutting order to region first. Then calculate. This is the spiral cut toolpath. In the Link and Lead tab, set the link type as blank plain. Calculate again. Here you can see the difference between the two parameters. Next, we will machine the 4 slots, still using the spiral cut operation. Hide the toolpath and right-click on Spiral Cut 1 to select Duplicate. Now we get the Spiral Cut 2 operation. Right-click on the feature and select Remove All. Then right-click again, choose Add. Click Create and select Profile Type. Pick the 4 small slots. Also, keep the type as Contain and click OK. Now, let's define the cutting tool. Right-click on the tool and select Manage. In the Tool Manager, input D10 as the tool name. Set the radius to 0 and cutter diameter to 10 millimeters. Close the dialog and click Yes to use the tool D10. Double-click on the parameter to make any modifications. In the Limiting tab, reset the top and bottom boundary. In the Path Setting tab, define the side finish type as None. In Link and Lead type, also set the type to None. And then calculate the toolpath. Double-click on the Spiral Cut 2 to hide the toolpath. Next, we will create the toolpath for all holes. ZW3D provides an auto hole tactic. In Cam Manager, right-click on the tactic and select Insert Hole Tactic. Right-click on the feature and select Add. Choose the part, click OK to finish. After that, right-click on Hole Tactic 1 and select Create or Calculate the toolpath. Then all toolpaths are created. Double-click on the operation and hide all toolpaths. In 2-axis milling ribbon, click Ramp Operation. Then click Create to define the new feature. Select Profile and click OK. Then select the 2 outer edges. In the Feature dialog, make sure the type is Contain and click OK. In the Tool list, select D10 as the cutting tool. Then pick No button to modify the parameters. In the Path setting, set the profile side to left. In the Limiting tab, set the top and bottom boundary. After parameters definition, click Calculate to generate the toolpath. This is the ramp cutting toolpath. Double-click on the Ramp Cut 1 and hide the toolpath. Next, create a Profile Cut operation. Click Profile Operation, then define the machining feature, choosing Profile 1 from the Feature dialog. In the Tool list, select D10 as the cutting tool, and click No, Don't Calculate the toolpath. Then define the parameter, Set the boundary. In the Path Setting tab, set the profile side to right and calculate the toolpath. After creating the operations, let's verify the toolpath. Right-click on Profile Cut 1 and select Verify. Then click Play Forward. Here we can see how the tool moves along the path. Also, here we can specify the tool start point. Aside from the toolpath verify, we can use the solid verify function. Right-click on the operation and select Solid Verify. In the Solid Verify session, click Run Simulation. Then we can observe the cutting process. Click Stop and then select the option at the bottom. Selecting Analysis and Visual, we can check the rest material during the cutting process. Click Close and click on the Solid Verify session. Double-click on the profile cut and hide the tool path. Next, double-click on the machine in CAM Manager. Input 2-axis milling as the machine name. And in the Post Configure, select FANUC Basic. Keep the rest in default, and click OK. Then right-clicking on the operation, we can choose Create Output for All. We can see that all operations are listed under P0001. Also, we can right-click on the output and select Insert NC option. So right-clicking, choose the Add operation. Press Ctrl and select Zigzag Cut 1 and Spiral Cut 1. Click OK. Right-click on P0001 and choose Rename. Rename it to P0002. Then right-click on P0002 and select Setting. We can change the part ID, the programmer, as well as the output folder. Click NC code at the bottom, then an NC code will be created. Next, let's output an operation list. Click Operation List at the bottom. It includes much information on operations, such as feed and speed, tool, machining time. Also, the default template can be customized. This has been the complete workflow of 2-axis milling.